Um, Good morning. It's the second session, so I hope people are a little more awake. I wasn't as awake as I would have liked to have been in my first session. But today, we're going to be talking about virtualized domain controllers. There are a couple of things in terms of thinking about them, which is about some of the potential problems that exist today and how we're improving them in Windows Server 2012. And we're also going to talk about a brand new concept in Windows Server 2012, which is your ability and our ability, because we own the security infrastructure underneath, to be able to take the OS for a full ride by cloning a domain controller, because we can create replica DCs through cloning. So we're going to talk about that in much more depth. Now, the key, I'm going to be spending a little bit of time talking about some of the challenges and the problems that do occur today. But at the same point in time, we're also going to talk about our improvements, and I'm going to, if the demo gods are, satisfied with me, probably we'll go through a few of the cloning scenarios, and I'll be able to explain a lot more in detail about certain aspects of what we do as a system when we go through a cloning process. Similarly, if there are any questions, I feel free to, this is a little bit of a smaller room compared to the last one that I did, so I would be able to take a few questions if it's really urgent. However, during the demo time as well, I will have some time when the cloned machines are coming up online to take a few questions, or we can do it right at the end. So I'm fairly flexible that way. So let's get started. How many of you have, I've asked this a few times, so if you're raising your hand again, please bear with me. How many of you have virtualized domain controllers? This is amazing from our perspective, because every year it's been changing. You know, about 2 years ago, barely 25% of the room would have their hands up, and we have more than about, probably I would estimate about 60% here. So the key thing is that virtualization is a fairly well-known and accepted concept, fundamentally because it really helps drive the right economics in terms of utilizing the hardware to its maximum potential. And domain controllers is just another workload that can be run on virtualized platforms, because just like any other workload, like file servers or IIS, so we can run on top of this platform and run at the full capacity of what the core hardware infrastructure offers you. Now, we've always supported running on virtualized machines. But the key thing is that before, and we've seen this through a slew of support cases, where specific virtualization actions, because people aren't truly aware, causes a set of problems for the Active Directory environment. We did have a best practice document that we upgraded sometime last year that told you exactly what are the key things to watch out for when you run domain controllers as a virtualized on a virtualized platform. Now, of course, there are certain things of virtualization, like you can copy a VHD into an existing VM. Those are things that sort of existed before. You could kind of ghost an image and kind of attach. Those things existed before, but at the same point in time, they became a lot more prevalent with larger adoption of virtualized platforms. Now, the other thing that we really noticed also was that Hyper-V admins were potentially different from domain controller admins. So what that resulted was that the Hyper-V admins were not well-versed with the set of things that you were not supposed to do with virtualized domain controllers, that also led to a set of problems that we were looking through from and got a lot of insight from our support data. Now, let's talk a little bit about the problem. How many of you know what a USN bubble is? Okay, that's good. All right. Fundamentally, the Active Directory is a distributed database. It has a series of complex algorithms to ensure and provide guarantees so that data converges across a multi-master system so that every domain controller in that forest has that same set of data. So if there were no changes that occurred in the system, all the domain controllers would essentially line up and converge so that the directory representation of the data is consistent across these nodes. Now, virtualization introduces a concept for us, or makes it more prevalent, where it really impacts the algorithm that Active Directory uses to ensure that data converges across all the nodes. Now, one of the key aspects is that the fundamental problem is that virtualization underneath us can roll back in time. Think of a simple case where you have a snapshot and you restore back to a snapshot. That is essentially a rolling back in time. But what happens is that Active Directory does not know about this. It doesn't know that you've rolled back in time. It doesn't know how to make sure that it can handle that case across dealing with this roll back in time. Ultimately, it results in a set of data potentially getting lost, where a set of data may only be available in some of the domain controllers, but not available in others. In addition, there's additional issues in terms of security principles that were created during the time, let's say, a snapshot was created and restored as well. So I'll walk through these in a lot more detail. So as you can see, as I show in the diagram, you essentially think of it as being something that's moving along a line. And the rest of the system, let's assume there are multiple lines kind of keeping track of this. And you just move back in time from where you were at, let's say, 7, and you move to 4. At that point in time, if Active Directory does not know about that event, it does not know how to handle it. Our overall algorithm is based on a vector clock algorithm. And pretty much any distributed system that is based on a vector clock algorithm is impacted by this. For example, there are cases where SQL replication is also impacted by this. So to explain this in more pictorial view. So let's consider two domain controllers. Let's assume a starting point of us being a USN is called an update sequence number. Think of it as being an atomically increasing number that is, with every operation in terms of changes to the directory, it keeps updating. It's a local concept. It's not a single concept across a domain or a forest. It's a local domain controller concept. But every other domain controller knows about it, because it is fundamental to how it determines what set of changes that it needs to accept and what set of changes that it needs to send. So that's all part of the core replication algorithm that Active Directory has. Now, similarly, think of ID. There's a certain ID for that domain controller, DC1, which is A. This is equivalent for us of saying what is known as invocation ID. Think of this as being, it is me, but if I change my name officially from Samuel Davis Ahayam to Yosemite Sam, let's say, that becomes a different change, even though it's still me. All right? Think of this as being, and everyone else knows that I'm now a Yosemite Sam, and if you were to kind of send me mail, it's a new email address to send to that. That's essentially invocation ID to the overall algorithm. From a set of relationships that we have a certain saying that as part of this state, then if you change the state to something else as an ID, then the rest of the system knows how to deal with that relationship in a feasible and deterministic manner. Let's also assume that we also have a RID pool. Every domain controller has a series of RIDs by which it uses to create security principles. This is the way we guarantee that SIDs are unique whenever we create a security principle. And you have a RID FISMO that essentially is the central role holder who decides and gives blocks of RIDs to the various DCs that need to create these security principles. Now, let's assume I took a snapshot at that point in time. And I moved forward in time where I just created 100 users. Now I've moved my update sequence number appropriately to 200. I'm still IDA, and I've depleted 100 RIDs because I created 100 users. Now, in the case of domain controller 2, it receives these updates because now it knows that it received stuff from domain controller 1 with ID of A all the way up to 100. So it knows that it needs to pick up these other 100 and have them also and converge that data across domain controller 2. Now, this is all fine and dandy. So let's now get to a place where we've applied a snapshot and we roll back in time. The virtualization platform does it, can do it, all right? But Active Directory knows nothing about this at this point in time. So where we are now is that I now create 100 more users. Note the fact that when the snapshot happened, the USN was what it was at T1. It was 100. The RID pool was still at 500 to 1,000. So which implies that, you know, for a new security principle, that I will use the 501st RID, which is used to kind of generate a SID when I create a security principle. Now when I go and create an additional 150 users, I've moved my USN all the way from 100 to 250. And now I've started reusing some of those RIDs that I had already used in the rest of the system that domain controller 2 already has. All right? And that essentially gives me from RIDs from 500 to 650. The RIDs from 500 to 600 have been reused in the system. So what happens as a result of that is that domain controller 2 essentially will only get updates from USN greater than 200 because it thinks that it is up to date with domain controller 1 of IDA with up to USN 100. So only 50 users out of the 150 have now moved over to domain controller 2. So we've just lost 100 users, and they will never, ever go to any other domain controller at this point in time. So that is a problem for us. Similarly, you will not be able to get back the set of users that were initially created by domain controller 1 from DC2 all the way back to DC1, in this case, when you roll back in time, which is also a problem. So now you've got divergent data where some users live in some domain controllers and others live in other domain controllers. So you've got these bubbles that exist in your enterprise. We've seen quite a few cases that showed up into our support channels, and this was something that we said, okay, we've got to figure out how we go fix this. Similarly, one more point that I want to kind of add is that because we've rolled back the RID pool as well, we haven't invalidated that RID pool, we've just reused a bunch of RIDs. What is the result of that? The result of that is that I've just created 2 security principles with the same security identifier, and that's a bad thing. The system knows how to deal with it. But the end result is that users who were logging in suddenly will not be able to log in because the system has already automatically disabled those accounts, and you're going to have a series of help desk support calls that will result as part of that. So again, in summary, 2 problems. Your USN bubbles with respect to impact of replication, where you're not going to have data diverge across all your domain controllers. And the second is that you will essentially get into a place where you have security principles that are being reused in terms of using the same RID and having the same security identifier, leading to a series of impactful conditions for your end users. Now, okay, we really saw this as a problem. Errors came through our support channels, and as part of our Windows 8 planning, we said, all right, there are 2 things that we really want to do. We want to make sure that we can embrace virtualization. All right? We want to make sure that we can make it a little safer for them, because it is a trend that we essentially cannot necessarily push back on. So how do we do this in a better fashion? Can we do something to make sure that we can safeguard? Because this is hours and hours. If you get into this condition, this is hours and hours of being able to work with Microsoft support and trying to kind of find the right solution, where in some cases people had to do a full a restore of the system to way back. In some cases, they had to spend hours to examine what the differences in data across the domain controllers were and try to redo those objects at that point in time to do that. This is painful. So we really were very focused, and we really wanted to make the right set of improvements in this area. Now, not only we started with thinking about it as being safe, but once we started spending more time thinking about it and working with a hypervisor team as well to figure out what is the right way to do this, because we are on top as a guest machine. If something happens below at the virtualization layer, we don't have any way for us to know it. If there are ways in which we have to go talk to the hypervisor team and work with them to say, are there ways we can enable some channel to be able to talk to each other so that we can detect some of these changes? So, and I'll come to more details on that. Now, that was where we started. And then once we did that, then we started scratching our heads and saying, you know, we've kind of got the core infrastructure in. What if we could really embrace virtualization to the next level? What if we could clone a domain controller? Because the most frequent operation that you might deal with deploying a domain controller is for a replica DC. And for the most part, these are all standard things that happen within an enterprise. For the right now, you don't support cloning pretty much all the way from domain joined machines all the way to excuse me, domain controllers. What if we could actually clone this from a standard image that people use because you have the most up-to-date data and be able to reflect that? Can we make this a much more simpler operation? And the answer was yes, we could do that, and we did that in Windows Server 2012, where you can now use a source domain controller running on a virtualized platform to be able to take that and say and stamp as many copies. Now, I'll get to this later, but the fundamental notion is you can think about cloning as a mechanism for you for thinking about quick deployment. You know, frankly, you know, for the heck of it, we actually wrote a script to say that we ran stress across a bunch of DCs in our environment and said, as soon as we see a global average of CPU being greater, all right, how quickly can I do a full automated clone of the overall system to be able to say, can I throw in one more DC automatically? All right? That was something that we did, and that was pretty impressive because we ran the stress system, and we could just clone another machine rapidly. In 5 minutes, we had another DC up and running across our set of domain controllers that's handling our authentication and authorization load. So that's a certain potential. Now, but the biggest thing that we think it potentially has for you is in terms of really thinking about forest and disaster recovery for forests. The amazing thing is that the cloning technology gives you the ability where instead of going through procedures that might have taken weeks for you to recover, you can potentially, based on how much automation that you have, can cut it down to hours or less, you know, in terms of hours, probably. And it's more a fundamental notion of how much time that it takes to copy a VHD and restart a machine is essentially the time that it takes for you to kind of get a bunch of these machines out into your necessary environments if you're ever going through a forest disaster recovery situation. Now, let's get down one level deeper, because I will be spending more time kind of getting a little deeper and deeper, and then kind of talk about a demo and then get into a few more details. Now, as I mentioned, fundamentally the problem was because the Active Directory environment did not know about a state change in the virtualization platform. So what we did was we worked with a hypervisor team, and we built this new concept called VM Generation ID. And it is nothing but, think of it as a GUID. But the hypervisor platform changes this GUID at every point in time that it thinks that a potential execution context, or simply put, you're rolling back in time. All right? Or you have potential to have rollback in time because the hypervisor platform may not know all the details. So essentially, it was fundamentally that. And we worked with the hypervisor team to provide that VM Generation ID and expose it so that we at the guest layer, the Active Directory component in the guest layer, excuse me, could read that VM Generation ID. And now you can, you know, it's a simple problem, right? Now we know of state changes. All we had to do is store that state within our own database for us to be able to look at it and say, all right, hey, this is what I have in the database. This is what the VM platform, the hypervisor platform is telling me. Is it the same? Oh, that's good. If it's different, we know there has been a virtualization event. And we can do the necessary things to handle that event. And I'll get to it in more detail. Now, you see the last one. Our fundamental focus was really to safeguard from actions and ensure that we can protect customers from these types of virtualization events. It is not our recommendation to use snapshot backup as a backup and restore mechanism even with this. We've kind of chatted with a bunch of the hypervisor team. There's a lot of differences in terms of the hypervisor platform vendors as well. So this is not a recommended action. And this is about safeguards and not about inventing a fully new backup and restore mechanism. So as I mentioned, the VM generation ID is a simple 128-bit identifier that is exposed to the Active Directory environment through a driver. So essentially from our layer, it looks like a BIOS setting. We can actually go read it off the, think of it as we can read it off the BIOS, where it is in memory, it is super quick for us. So we were able to use this in our design pretty effectively because we can detect conditions whether someone actually had a running Active Directory and restored, took a snapshot and restored. So we detect that on every commit of a database transaction. Or when we first start up, we can also do that and check that. I'll cover that also in detail. So now we have the ability to kind of compare these and do the appropriate actions. Now, one thing to note is that we had most of the core technology, all right, to handle these things. It's just that we didn't get notified for us to be able to trigger or necessary changes. Like when you restore from a backup, what we actually do there is that there are a series of actions that already happen. For example, there are two things that you may already be aware of, but let me mention that. One is the notion of invocation ID. That was what I kind of called as IDA in the slide that you saw earlier. And the other is the notion of the RID pool that was also there. So we already do it when, in a restore event, we automatically change our invocation ID because it helps the rest of the algorithm to essentially start saying, oh, OK, it's DC1, but with a new ID 2. So I need to push some changes. I need to pull changes so that we can all converge there. Similarly, we also invalidate the RID pool so that we wouldn't reuse those RIDs, and we would ask a new RID pool from the RID FISMO at that point in time so that when we create security principles that we would not necessarily be using RIDs that were already being used. So this was already something that we already had support for since Windows Server 2003, I believe. So all we had to do is once the hypervisor platform provided us that ability to notify us, we had to kind of integrate that into our code to make sure that we could do the necessary things to automatically reset ourselves. So I'll get in more details. So there were two places we fundamentally think of this. So think of this saying, I've got the hypervisor platform provides us with this VM generation ID. We always store what is our last known VM generation ID into our database. And there are fundamentally two places where we do these checks. One is at startup time. Quite simple, right? Logical. Is that when we start up, we go and check to say, all right, let me read the VM generation ID. Let me check in my database to see. All right, does it match? Oh, no, it doesn't match. So it implies that there's been some event, and I want to make sure that I go into my precautionary mode. So I'm going to be safe. I'm going to reset my invocation ID, and I am going to also invalidate my RID pool and get a new RID pool when I start up. So during that startup process, the domain controller comes up and then invalidates its RID pool, resets its invocation ID, tries to do a replication sync, as well as contact the RID FISMO owner for getting a new RID pool so that it can, once it's up, it can start servicing requests and create new security principles. Similarly, in the machine reboot, we also do that during any database commit in our transaction as well. because any updates that happens, this is to catch the condition as I mentioned earlier. Let's assume that for some reason you snapshotted during an execution where the Active Directory is up and running, all right? Because that's not in the boot up path, and you restored at that point in time. So the next update that happens will will go through the same logic, be able to check for what's there from the BIOS that's provided by the hypervisor platform and what's there in our database. And if they differ, it will automatically reject that transaction. That's one transaction that will get rejected, and will essentially reset the invocation, change the invocation ID, and reset the RID pool so that we get a new RID pool. In terms of FSMOs, like I mentioned, we do deal with the replication cycle so that we are most up to date with the FSMO role owners at that point in time before we announce ourselves at this point in time as well. So these are the core capabilities that we've put in Windows Server 2012. This is I always it's a good segue for me to say is that this is not, while we've worked with a hypervisor Hyper-V team in Windows Server, it was our goal also to make sure this is not from an Active Directory customer perspective. We wanted to ensure we were doing the right things across all hypervisor platforms. So we actually build a generic specification on terms of what a hypervisor platform needs to do, and some of the wording is from the specification, so it looks a little obfuscated to me, but at the same point in time, this is part of a specification, and we are working with the key major hypervisor vendors to also do this as part of their newer platforms, so that Active Directory on any of those updated hypervisor platforms across different vendors can continue to operate this way and be safer as a result of that. Okay? This is, again, a quick pictorial view that's comparing what it was. This was all the same. So now you can see there's a new saved VMGM ID and the actual VMG GID. You now notice at time T3, when we came back from a snapshot, you will see that the VMG ID has now moved over from G1 to G2. But the state in the database that has been saved is essentially still G1. So this is where we detect the logic. And you notice from ID A, we have moved over to ID B, and we have changed the saved state to G2. This essentially results in us being able to converge on the data across the various domain controllers, such that changes that were made during that period, even on my domain controller that were replicated out, come back to me, and anything that I make new is freshly sent out to all the other domain controllers. So those are the changes that happen as a result of that. So DC2 now, because the ID has changed, it accepts updates of greater than 200 and knows about, when it stores its state, that it knows that it is now up to date from DC1 with invocation B, ID B, all the way up to 250. So this is the way we guarantee now that data starts converging across the rest of the environment amongst all the domain controllers that need to replicate the information. Excuse me. Now, let's talk a little bit about cloning. Now, as I mentioned, there was an aspect where our first goal was to provide the necessary safeguards. And I'm going to keep repeating again, it's not a standard way you're going to do system backup and restore, so please remember that. However, this led us to going a little further and examining some of the things that we can do with the virtualization in mind. Now, let's consider what your standard disaster recovery experience across this type of an environment. How many of you have multiple forests? Okay. How many of you have multiple domains? All right. So it's about, we're seeing in the last 1 to 2 years, I would think, we're seeing a lot of focus on collapsing both domains and forests as well. So that does simplify certain problems. But let's consider this to be the same forest as well. And you have 3 domains. And typically what you do is that as part of recovery, you've done periodic backups. And so you're going to have restored, you'll be going through and restoring the first DC in every domain in your enterprise. Now, moving forward, post that, you have a series of ways in which you might have opted to do this. You might either have said that I'm going to just have to set up the machine and I'm going to run through DC promo and make it replicate all the data and then wait for it to kind of finish, and then that's my thing. And I'm going to be doing that across all, how many ever DCs that I have in the domain, I'm going to follow that process. Or you might have the option where you've taken an install from media, from potentially you're running that across this first machine that you have out here, getting the install from media, pushing that over to the necessary target machine, and then running through DC promo and promote that to a domain controller using that install from media. This is perhaps really tedious. In talking to some of our customers, they anticipate that their disaster recovery plan would take them 3 weeks to get fully operational as part of doing this. And that is potentially loss for the business. All right, as you can see, I'm going to go through a series of actions out here. There are certain parts that can be automated, for sure, but at the same point in time, it's fairly error-prone. Now, what we did as a result of some of our improvements in virtualization is that we now have the ability to kind of clone these replica DCs, and I'll go through this in more detail, is you just require one DC to be hosted on VMs, and which is used to seed the cloning process. Similarly, we still require you to restore the first domain controller using stand-up, backup, and restore mechanisms. All right? Like I mentioned, snapshot and backup restore is not a valid mechanism. We're still required to do that. The nice thing about it is that it is the safest choice, because it sets the necessary invocation IDs. You're back across a multiple domain environment. You're back to resetting your identity of sorts, and the rest of the infrastructure will be able to handle that and converge appropriately. And this is the reason why we still ask you to do the first DC. But once you're there, you can essentially set up as many replicas through the cloning process, and you're pretty much gated by the time it takes for you to copy that VHD and restart the machine. And our cloning time is not very long in our startup process. You'll see that in the demo, where it's not a function of your database anymore. It's a function of a set of deterministic operations that we have as part of that. So this is a potential way for you to do a forest disaster recovery plan within your environment or within your customer's environment. So let's see what that looks like now. So you're still doing the same thing as I mentioned. But now, the nice thing is that a whole bunch of these can just be clones within the environment at this point in time. I'm not replicating data. I am just copying a VHD that already existed, and that's a standard mechanism. There's a pretty easy way for whoever's used to a virtualized platform. And I set that up, and I reboot the machine with a specialized file. I'll get to those details in a bit. And that's all I do. I reboot the machine. The machine says, oh, it seems that you want me to clone myself from this original VHD that I booted up from. So let me do a bunch of things to kind of clone myself. I've got a set of parameters that were provided as part of me provisioning that file into this source DC of sorts. And from there, I can set up do the cloning operation, and I'm back up and online. So which implies just a few set of operations that we do as part of that. So that is the potential that cloning gives you to improve the time that it takes to recover in a potentially bad situation. Again, these are a few things. I've already kind of mentioned a few of these. The key thing is that we believe that the cloning process is a lot faster in terms of getting to, we've done some preliminary tests, it's a lot faster in terms of getting a replica DC up and running because we have everything except a few things in terms of the domain controller accounts, a few things around FSMA role handling. Those are the small set of operations that we have to handle as part of bringing up a new clone DC. So as I said, cloning probably can helpful, like we did this test for elastic provisioning. You can think about using that for building your test environments potentially, but it doesn't change the fact that we don't give you the way to kind of isolate yourself. You have to still follow the same standard best practices that we give you to say you need to isolate those domain controllers in the network to make sure that they don't collide, and those things can be pretty bad. Or the branch office. Now let's get into a little more of the details, and I'll walk you through what it means for the cloning operation. Excuse me. I seem to have developed a cough. Now, the first step is that you always need a source. You need the seed from which that you clone from. This, hopefully, is your most up-to-date environment, and you're using this as the source from which you build the VHT that you copy over to be cloned as multiple instances. Now, the second, excuse me. Now, the second step is that, now, of course, domain controllers are really key security infrastructure. You don't want to allow domain controllers to be cloned very easily. So what we did is that, and you don't want every domain controller perhaps to be cloned as well. So what we did was that, excuse me, we built an authorization mechanism where you have to add a domain controller to be cloned to be part of a new well-known group that we've created in Windows Server 2012. And that is called the Clonable Domain Controllers Group. So your domain controller computer account has to be part of that group for us to let you clone that seed. So this gives you, by default, the security descriptor is for domain admins. So it gives you the control to say who do you want to ensure that gets added to that group so that you can control the seed that and authorize that domain controller to be cloned. Now, the third step is where you can provide some level of customization to your cloning. By default, if you create a file with no parameters, we have this new clone config file, and we've also created a new PowerShell commandlet to support that. If you, by default, if you don't specify parameters, we select all the parameters for you. So these are the standard things. Think about it as computer name. Think about it as IP address, because you already have a static IP address available for your cloned domain controller. Think about it as your DNS settings. There are a few more things out there as part of that. Now, the next one is essentially where is important, because think of, we are taking the OS for a ride, right? Within Windows, we went through a rigorous mechanism where we worked with the various Windows components to make sure that when we clone those Windows components, they wouldn't essentially falter, all right? So they would be able to handle that. So think of it as being sysprepping those components. And in some of those components, as part of our cloning process, we actually go through a sysprepping mechanism for those components. So we call into the sysprep providers of those components so that they reset themselves, thinking about it as being a new machine, and they can start working seamlessly as before. However, one thing to watch out for when you're doing cloning is that not every application that you might have on that seed machine is suitable for cloning. So to prevent occurrences where you clone something and then you realized much later that that application did not work well in a cloning environment, causing errors potentially and more support calls in you, what we did was that we check the source DC. Whenever you create a config file, we check the source DC to see, do we see any applications that's not part of our well-known tested list. And if we did find something, we will refuse to allow you to clone that source DC until you as the administrator are validating that application is suitable and you've added that application to a well-known, I'm going to allow this to be cloned list. So this is important because it is important. This typically becomes a one-time investment for admins because you have a standard set of applications. It's not very many that run on domain controllers, but you have a standard set that runs on them, and you can have the ability to kind of validate or work with the vendors to say, can I clone this, and get a response back and say, OK, that's good. I'm going to be able to kind of go get this cloned and get the benefits of cloning as part of that. We deliberately said we want this to be an explicit action because we know of certain applications that can't be cloned. Now, yes. So if I understood the question correctly, the config file is after your cloning operation has completed. Yes, because every time a machine gets cloned, I actually have a slide with details in that. I'll get to that. Yes, one more. What we were worried was we weren't going to, so we're kind of creating the full OS, and you will see that, and I'll kind of showcase that in the demo, is that we're not necessarily deregistering components as part of that, cloning that full OS. So if, for example, you had a program in control panel that was out there, we do not know what you want to do as part of that, whether it's needed or not. So it is difficult for us to say, we're bringing everything in as part of whatever you've said is OK to kind of go bring in. And that's kind of why we did that. We're not deregistering components and removing components like an OS image does when it is. Like, for example, the new CBS setup in Windows actually builds like a full migration kind of set of the things and re-registers all of them once a clean OS has been set up. That's not what we're doing. We're kind of bringing that full OS with some changes to the security infrastructure. All right. Yeah. Yes. Yes. Now, we are still going through some final aspects of closing out on that guidance, so we will provide that guidance. So right now, we were still in the position as requiring at least one domain controller in a domain to be on a physically backed hardware. All right. So, however, we're trying to see if we can change that guidance and move over. We need to complete some of our validation routines, and we'll update that guidance appropriately. So the yes, yeah. Our seed has to be from a virtualized DC. Not necessarily. Not necessarily. What we've done as part of the FSMO is that as part of the cloning, those FSMO roles are not there anymore. So if you want them to be there, you can go add them. Because technically, it's a replica DC at that point in time. That's how we treat it. So even though if you source from a DC that has one of those FSMO roles, we wouldn't necessarily create ourselves to be a FSMO role owner. So we do the same process out here as well. That's saying that the FSMO roles are all cleaned up, so you don't have it. So if you're coming from a disaster recovery position and you need to update the FSMO role owner, rather for some of these machines, be able to set them to be a FSMO role, then that's something that you'll have to perform. All right. So so I've talked about the excluded application list. This is something that you'll have to kind of keep in mind. Now, once you do that, typically it's a one-time task, is that all you have to do is shut down and export the source DC to a VHD. And once you've copied that VHD over, you can pretty much restart that source and you're good to go. What this does is from that source copy, you can now create as many clones as you want. And even if you want to customize your configuration file, like let's say you care about the naming, because by default, if you didn't give us a name, we'll create a name for you. All right, if you create it, you can still mount that VHT and modify that, customize, and all of these, for example, can be scripted fully. So you can look like a disk for you. You can access the file and be able to make the appropriate edit onto that file and be able to customize on a per VHT basis whatever you need for a per clone as well. Oops. Ow. I still need more coffee. I wish, but so as I mentioned, this is pretty much a pre-setup process for getting your source DC set up. It's typically a one-time task. Think about it as your potential one-time standard, an equivalent to backup, but think of this as being a way you kind of have these already. Now, I talked about the clone config file. By default, we have a series of settings, and these are not all of them. So this is just an example. It's just a standard XML file. We have both a schema for the XML file located, as well as giving you an example XML file as well. You can set the name, the site to which the DC belongs to, the IP address, standard things that you think about even in your DC Promo 10 file that you might be providing as part of setting up a replica domain controller. These are all out there. But key thing is that across this, it could be empty, and we take care of all of it for you. So we assume that you want DHCP address at that point in time. So we assume that we get the DNS server from the DHCP settings. Those are certain things. But you also have the full flexibility to control specific things within this DC clone config file. As I mentioned, limited set of programs and services. It's already part of like some of the standard things like DNS, FSR, FRS, and DFSR. How many of you still use FRS in your environment? Sorry? No, it's still there. But I was curious to find out how many of you use FRS. So I saw a very few set of hands. It's still out there, but this is something that we also included as part of our excluded application list that we actually went and validated across them. Now, like as I was mentioning, there's a series of components in Windows that have the capabilities as part of our core sysprep mechanism to be able to reset themselves. So we worked with each of these Windows components to actually go and ensure that we're calling the appropriate resets so that when they come back on that reboot, they look fresh. And they can essentially, it looks like a new machine that kind of came up with that, and they can work seamlessly. We validated this across, and we did a lot of testing across the whole of Windows to actually do this. We actually been running we have this process called dog fooding whenever we do Windows. And there's a series of domain controllers that are kind of keep updating build to build. And we have about 5,000 to 10,000 people on a separate forest that essentially goes through the rigorous, as we do builds, we keep updating new functionality. And we actually went through a full process of actually going through cloning, and it's kind of happily up and running, so we feel good about that. Now, in terms of file locations and precedence, this is kind of important if you want more customization. Now, fundamentally, the DC clone config file is expected to be first in the DIT folder, because the DIT folder could be, you typically have different drives that you place your DIT in. So we first look at the DIT folder, and then we look at the percentage windir WAC NTDS folder, because in some cases the DIT is not in that same location either. So we made sure that we captured for both of these. We also saying that if you needed it because of virtualization, because you can still attach potential virtualized drives to a certain machine, a virtual machine, we also check the root folder for this clone config file so that across this is the precedence order for us. We'll first check the DIT file, the DIT directory, we'll check the NTDS directory, as well as we check the root of every available drive to see if we can find a clone config file. Similarly, if you want to customize your applications to say that these are allowed to be cloned, then you can either set through a registry setting a special folder, or you can, it's the same set of things that you saw earlier where we check the did folder, the NTDS, and root of any removable media. So one of the things is that, so this gives you the ability also to kind of make this available through sysvol as well. All right, I'm going to now get to my demo. Is this visible at this point in time? There's not much out here, but I'll show you in another set of screen. But I just want to make sure. Folks at the back, can you at least see that you differentiate between a PDC and a source? All right. I'll keep going. Excuse me. So I'm going to go to my source DC. So before I mentioned that, in our RC build environment, you cannot clone from a PDC. But that was a bug fix. That's been fixed. And that you can clone from a PDC as well. So for this demo, I have two DCs. One is the PDC, and one is the source DC that I'm kind of cloning from. So as you can see, that I already have the source DC out here. I'm in ADAC right now, which is Active Directory Administrative Center. So I go to the domain controllers. All right, and I right-click, add to the group. As I mentioned, the first step is to allow a DC to be cloned is that that domain controller must be part of a well-known group. If it is not, we disallow any aspect of cloning. So let me say clonable, check names. As you can see, it's a well-known group. It's already out there. And I've added it. So now at this point in time, the source DC is authorized to be cloned. So when a new machine comes with that, so think of it, when we boot up, we think of ourselves as identity A, which is the source DC. And then we find this clone config file. So at that point in time, we have to say, OK, can I be cloned? So when we do that, we actually go and validate at that point in time that this DC at this point in time, because we haven't morphed ourselves into a new domain controller, can be cloned as part of this process. And that's all I have to do. Now let me open up a PowerShell window. Say import module Active Directory. All right. So now the first thing that So as I mentioned, we added a PowerShell capability that will go examine the source domain controller and say, let me go check all the programs that were registered in control panel. Let me go check all the types of things that running processes to see, is this part of our well-known list? All right? If it finds things that it doesn't know about, it will complain. At this point in time, this machine has already been, is clean from a core perspective. So if it was a fresh machine, it would look clean this way. We actually go validate that across the board, and we say, do we detect something or not? If we did detect, we would let you know what those set of applications were so that you can go now examine and decide whether you're going to add them to the excluded application list so it becomes whitelisted for cloning. So once I've done that, the operation that I do is to create the clone config file, because I then store it on the source DC, and then I'm off to the races. So I said new ADDC clone config file. Now, as you can see, let me run a get help on it. Like, for example, each of the set of parameters that you've seen, you saw like an example of that XML file. What we've done is given you a PowerShell capability so that a whole bunch of the parameters, including computer name, my Win server, my IP address, can all be specified by these parameters, and you can create this, and we will create that config file for you automatically in the DIT folder as part of the first location in our precedence list. So I might have said minus clone computer name is my clone 1. And let me show you that. Now, as part of doing this, now you see the first check out there that happened was that we went and made sure that the PDC was Windows Server 2012. And let me explain to you why we chose to do that. Let me just see if I'm doing on time. All right. So we took the PDC at that point in time and said, the reason why we do this is that for the series of operations that we do to authorize, I already talked about the fact that there's an authorization step that happens there. And as part of making sure that we can do that and check a few more conditions so that we can do the right set of validations, we do require the PDC to be Windows Server 2012 at this point in time. Now, the second check, as you can see, is that we do check to see that this machine already, when you generate that clone config file, has already been authorized. And the final check that we do is that we run the check that I ran before, and it needs to pass that says that everything on the system is allowed to be cloned. Now, that's all I had to do. And if you can go see this clone config file, so you can see that it automatically created that clone config file with a new computer name that I just passed through the parameter. What I'm going to do is because I want to show multiple clones that happened right now, so I'm going to delete that file for a second. And then I'm going to recreate this without any parameters. So now this looks empty because that computer name is not there, and we just take defaults. And I'll show you how those defaults were created. Let me stop the computer. All right. One question. Any question? I can take that while this comes up. Any with me so far in general? All right. No. It so happened that we owned all the core security infrastructure. So, sorry. The question was that given that there's some capabilities in the hypervisor platform, and we as domain controllers have the capability to clone, does this extend to other Windows 8 clients, member servers as well, to do this? Is that valid? Yeah. Yes. So is this possible to clone member servers running on hypervisor platforms as well? I actually didn't get that question then. Yes. The Hyper-V on the client, it's the same code base. So it should work. The key difference only now as part of those hypervisor changes is that set of hypervisor changes is not currently available on Windows Azure virtual machines because that's running a slightly older version of the hypervisor. It doesn't have that. But over a period of time, we have that. And you should be able to do that on a Windows client machine running on the hypervisor platform. But I will confirm as well. But yeah. Oh, no worries. So as you can see, the machine was stopped. So now the only thing that I did was, let me bring up. Okay, this is my environment where I actually used a diff disk, and I'm just going to, so that it's easier to copy. Copied that. All right. So let's call these two different things. Let's call it clone 1. And let's call this clone 2. All right. And that's pretty much what I did to kind of copy. So once I've copied, I can restart my source DC. So that should be good. I will do that. And let me create a couple of new virtual machines very quickly. Clone one. Next, 1024. Connected to the demo. I'm attaching this to the virtual disk that I just copied over. So I'm going to use clone 1. And create another virtual machine as clone 2. 1024. Next. In this case, I'm attaching the clone to virtual disk. And that's pretty much my operation. And we're going to start this. Start this. So it's going to go through the cloning process. So I'm already all right, so I've just started the cloning process. What I did was just copy those VHTs attached. Now remember that we already have these cloning config files there. I can take a couple more questions while this kind of comes up. Yeah. It becomes a global catalog and a DNS server. Yes. Yes. Because there's a lot of data out there. You typically want it, so that's a good thing for you to have. So is what we've decided. So, so just let me kind of explain what happens as part of the overall process. Now, what happens is that we boot up. At that point in time, we first, because I just created a new virtual machine, hypervisor actually changed the VM generation ID for me. So we say, oh, VM generation ID is kind of different, so we take that code path. And there's a few more code paths. We wanted to make sure that we covered all the varying cases in which people get it. And as you can see that now the system has already detected that it needs to be cloned, so it's currently going through a full cloning process, and we actually are showing you the progress as part of doing this. Now, once we detect that cloning config file, we say, OK, looks like it's good. There's a set of data within the config file that we have to adapt. So we go and then say, OK, let me go make a check against the PDC to say that can I be cloned. We do the authorization check. And then we go create the necessary new domain controller accounts as part of doing that. Now, the interesting thing about it is because this is where it's hard because we're the security system. So we can understand what we need to do and make sure we provide the right safeguards. We use the context of our old for our current security account, which is that source DC, to essentially go and create ourselves a new context as well. So this becomes so that we can do that in a secure fashion. And that's something that we do and we can provide. And we've created a new domain controller account. Once that's been set up, the rest is pretty easy. We have to reset a few things amongst our local database. We update the VM generation ID. Then we, as I mentioned earlier, we take care of the FSMO role owners. We do the necessary calls within the database to actually take care of all of those. And then we initiate a full replication sync, and then we start coming up. So that is the fundamental process that's involved in the cloning aspect. Now, there are a few more things is that there are cases in which we have to protect ourselves. Remember, the fact is that if you notice, I restarted the source DC, right? Now, the source DC had a clone config file because that was where I created to actually go seed the clone config file. All right? But when it started, how do we know that we are not trying to be cloned? And that is why we actually took a dependency on the VM generation ID. But if you notice, on the restart of a machine, the hypervisor platform hasn't changed in time its context. So it doesn't change the VM generation ID, which results in the fact that we now know, oh, VM generation ID provided by hypervisor platform matches what we have in the database. Hey, but I still see a clone config file. You know what I'm going to do? I'm just going to rename that file away so that I don't have to think about it, because it implies I'm booting up in the context of who I am supposed to be. That is essentially what we do. Looks like we've logged in. We've not logged in, but we've booted up. And this is now a fully functional password. Yep. So this now, so one of the interesting things is that because we cloned the whole OS, you notice that I actually added in my source DC, I had ADAC in my customized to my taskbar, to be attached to my taskbar. And pretty much the full thing kind of comes out here because I have the same experience out there that I had on my source DC. So I open up ADAC. And if you now notice, this is the new clone DC. And it actually has, from what was just the source and the PDC machines as part of the domain controllers, it now has two new machines. That's called source-CL00001 and 0002. What we did was, because I did not provide a name, the way we pick defaults is we take the first 5 characters of the source DC's name, and then we add, you know, an ever-increasing number. This is also a way in which we actually, why we go talk to the PDC, we try to find what is the best name as part of that and get that piece of information as well. So that is, in a sense, how simple a full cloning operation could be. Note that, I'll just get in a second. Note that I can do all of these operations even through the standard virtualization PowerShell commandlets that's already available with hypervisor in Windows Server 2012. Yes, I had a question here. The IP addresses in this case, because I did not supply anything, my PDC actually was hosting a DHCP server as well. So I was actually picking it up through DHCP at this point in time. But if you did not, you would be able to set explicit IP addresses or set DHCP server settings as well as part of your clone config file so that you get the necessary IP addresses. Mm-hmm. Yes. I don't remember the exact logic that we actually do that, but for the most part, that if you did not, if we were a DNS server, we would use ourselves as a DNS server as part of that. Yeah. Yes. Sorry. Yes, clone DC will fail at that point in time. What we do is that as part of it, when we fail, for the most set of our failure conditions, we boot up into DSRM. Because we do not know what is the expectation, because if you did something wrong, or was it expected, or is it something bad that someone is trying to do, we just boot into DSRM mode and saying, okay, admin has to take an explicit action at that point in time. I had a question here. So again, yes. The defaults are all making sure that we build deterministic algorithms. We have algorithms in which we will have uniqueness. Now, in the case where you either need a static address or you need DHCP. So we do all of those checks for you as part of doing that. So DHCP will take care of not having IP conflicts at that point in time. Similarly, names, as I pointed out, we create distinct, unique names. And because we're going to the PDC always at that point in time, we can make sure that there are unique name checks. that happens on the post boot. The way I called the clone 1 and clone 2 was purely just the disk aspect of it, but that hasn't changed the set of domain controller accounts or aspect of that. I had a question there first. Yes. Yep. Yes. So in that case, the generation ID does get changed because we have to be safe across the set of cases. So if you were creating a new virtual machine, let's say on a different host, so at that point in time, it is a new generation ID for us. But the only thing that happens is that we reset our invocation ID, and we essentially will invalidate our RID pool to be safe so that the rest of the system can continue to operate seamlessly. So the question, by the way, was that what is the impact if I'm just moving a machine, a virtualized DC, potentially from one host to another? Yes, those are everyone. So like I said, what you would do in that case is that you would set up like the source with some base config file, all right? And then you would use just PowerShell to pretty much mount the disk and then make the changes across each of them as you see appropriately. And you've got all your disks. You ship the disks to wherever you need to ship it, and they can set up the virtual machine, start it up, and your domain controller is up and running. Okay. All right? Yes? Are you talking about the Hyper-V migrate? I will need to check back on that. Okay, yes? Sorry? I don't have the exact thing, but we are working with VMware on that. So I believe, again, it's not for me to kind of say, but we are working for them, and they will provide the necessary timelines about it. Let me just kind of, I already showed all of these things. I've talked about some of these things. As I mentioned, a few things, the invocation ID, I'll keep repeating it. I think people are pretty familiar with it now. We talked about FSMO. Now, as you said, this is kind of one interesting flowchart, is that when we boot up, we look to see if the generation ID is available. If it's no, which means potentially this is on a platform that does not support VM generation ID, I still found a potential DC clone config file, which means no, we don't allow it, so we essentially boot it up into DSRM mode. Similarly, yes, it is available. Has the generation ID changed? No, all right, because it's still running. Now, this is the case of that source DC. This is the path where we're booting up the source DC again. Does DC clone config file exist? We rename it, and we boot it normally. Then, yes, has generation ID changed? Does DS config? And we perform the cloning process as part of that. Right? All right. Seeing a lot of people take pictures of this. But by the way, you do have this deck available to you, so feel free to download and pick it up from there as well. This is more detail in terms of how our core code works itself. And I'm just going to, I think I've already talked about this thing. So the right portion is essentially about the PDC and how we kind of deal with some of the checks and handle code associated with that. So as you see that the PDC is the one that generates the new machine name, so it provides uniqueness as well and the necessary machine account and the password. Again, it requires Windows Server 2012 hypervisor platform and is 2012 domain controllers only. So your source DC has to be running on a hypervisor platform that is capable of VM generation ID and running Windows Server 2012. Similarly, this does not handle the case where you essentially are going to just copy a VHD and attach it to an existing VM. Because in this case, most hypervisor platforms don't know that something has changed as part of the underneath and cannot provide the necessary notification to the Active Directory layer. So in summary, I guess I hope people see the fact that we did two things. One is we tried to make it better to be safer on virtualized hardware, to make sure that standard things that if you did by mistake, you roll back in time, it does not have adverse effect. And similarly, we've kind of enabled a new branch in us embracing virtualization by providing you the capability to kind of clone, which is applicable to various scenarios around deployment, including disaster recovery for your forest. So thank you so much. If I can take a few more questions, probably one or two, before we finish. Go ahead. Sorry, you raised your hand, sir. Yes. 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 You can do a P2V essentially across. There are standard tools to be able to help you do that. And that's a good place for you to start as well. The question was, can I move from physical to virtual through using these standard tools and be able to utilize this? Yes. Anyone else? Yes. Does Data Protection Manager understand any of this? We're working with the System Center Virtual Machine Manager on some of this, but not right now. So thank you so much. We're going to be there at a Q&A session again at lunch. So we'd be happy to entertain more questions if you have. And I will be available after the session as well. Anything around Active Directory, Federation Service, it's all up for fair game. So we always love to hear feedback from you. So I hope you enjoy this session. Thank you very much.